Okay, so here we are with our site down here, the one we were just looking at in the previous video, except now you'll notice we're kind of zoomed out here and we're actually kind of looking through this purple window because this is all one big paper space. This is what it would look like if I went to print it out. So I'll show you more of that in a second, but this is the site. And you can see some of our contour labels here. You can see the contours. You can also see the flow path here of the creek center line. This is what's called a reach. It's connecting from this area up here down to our study point. And then this orange line here that we've drawn in, that is what's called the time of concentration flow path, which we mentioned earlier is how long it takes for the watershed to respond to all the rain in the area. And speaking of area, here are the sub-basin areas, these large dashed yellow lines. So you can see that there can be many of these. Oh, takes a little bit to work sometimes. But we have all these different ones here, and this is actually a huge watershed. There are tons of these sub-basins as we zoom out, and they all have their own time and concentration flow path. Some of them are connected by reaches. There are areas that we have to add up. We have to figure out whether it's commercial or residential or park land use in each of these. You can see some of these have a lot of residential. Some of them have maybe more farm or just open fields. So we have to take all of this into account, and then we come into a program called HMS, and what we do there is we model that entire setup. So if you remember, we had sub-basin Z that is, down here, and it has an area of 0.93779 square miles. That's miles squared is what that's supposed to be right there. Then we also have the amount of loss based on a curve number. That's just all a fancy way of saying how much water gets absorbed into the ground and how much runs off, like we talked about earlier. And then this is the lag time, which is determined from the time of concentration flow path. Again, this is just the water, how long it takes to actually get to and peak in the watershed. So again, you've got the area, you've got how much gets absorbed and how fast all that water congeals into the middle and actually reaches its peak. Then we just come up here, we do what's called a 100-year run because I'm trying to figure out how much flow is going to be produced by the 100-year storm. I select the run button, it runs its calculations doing the Manning's equation and all of that in the background. And so you can see that it's working. There we go. And now at that study point, I can determine that I have a flow of 9,413.8 cubic feet per second. Which, if you're wondering, is a cubic foot is basically the size of a mini refrigerator. So imagine some of those small mini fridges and then imagine 9,413.8 of them trying to flow past. That's how much water we're talking about.